From Chicago, welcome to 3Degrees Discussions. I'm your host, Mike Vasquez. This is a podcast devoted to the stories behind the innovators, entrepreneurs, and leaders in the 3D printing industry.
I'd been doing 3D printing in high school and then, a little bit in college here and there, more so like just plastic stuff. And I would say how I got reintroduced introduced to additive manufacturing instead of 3D printing was I had the opportunity to do a summer internship at the Alcoa Technical Center, ATC in Pittsburgh. And they had an M270 machine, and I had the opportunity to get involved with some projects there. And I was like, wow, this is really cool technology, and it's really going to change the way we make things.
That was Jacob Rindler. Jacob is the lead additive manufacturing engineer at the Ohio State University's Center for Design and Manufacturing Excellence. Before joining the Ohio State team, Jacob developed AM and advanced metals technology at both Northrop Grumman and Boeing Research and Technology. Jacob attended the Ohio State University, where he holds a bachelor's degree in Welding Engineering. Before we get started, head over to www.3degreescompany.com and subscribe to the podcast. Remember, you can listen to the show anywhere you download your podcasts, including Spotify, Apple, Amazon, or Stitcher.
Well, Jacob, thank you so much for joining the show today. Why don't we just start kind of from the beginning with your career? Was there something that drew you into engineering, manufacturing early on as you were thinking about your academic and career path?
Well, hi, Mike, and thanks for having me on today. I would say, in high school, I actually had the opportunity to take part in a pre-engineering curriculum at my high school called Project Lead the Way. And, they gave us introductory to, CAD and AutoCAD, and being a lifelong, childhood fan of Legos, it started just kind of building off of that, and really moved into more advanced classes. We even did some stuff with like CAM and, doing some CNC programming and some digital electronics. And I just kind of really ate it up and went with it. And actually, come my senior year, we had a capstone project working with a local manufacturer to develop some automation for some of their processes. And this is actually where I got my start in 3D printing. We started printing some robotic end effector tooling. This was back in 2010. So some state grants enabled us to get a FDM printer, and when they were still, very expensive. So that's kind of where I got my start in 3D printing. And when it came time to pick a university, Ohio State was a big draw, and I decided to keep moving forward with my engineering education at the university level. So.
And was there ever a particular industry that excited you, or kind of seeing kind of some of the applications that you were hands-on with that particularly drew your interest?
So I grew up on a farm, actually, and my initial thought was I wanted to be in the agricultural industry. And so I started off in agricultural and biological engineering as my major. And I thought, growing up, being on the farm, I was like, oh yeah, I don't know, I'll figure out how to design better tractors and put my, hands-on knowledge to use to design better implements or better ways of, doing things in the agricultural field. A couple of years into school, I don't know, I guess I kind of, as people do in university, they open their eyes to other opportunities and things like that. And that's kind of how I got into welding engineering and materials and metallurgy. So that's kind of the progression there.
Yeah. And so was welding engineering a degree? Was that kind of the official degree that?
Yes, actually. So Ohio State is one of just a handful of schools that have a degree in welding engineering. We're like the only quote unquote ABET accredited. Some of the others are more welding technology degrees. Us and Cranfield University, I think, has a welding engineering program, Cranfield in the United Kingdom. It's, it seems very specialized, but, looking back, it's kind of an amalgamation of mechanical, material science, and some electrical aspects, really focused on not even just welding, but joining in general.
And so how did 3D printing play into that at the time? I mean, this is kind of what you said, 2010, 2015 timeframe, right? And so like DMLS had been invented, like there are some machines. Was there any talk of that in the curriculum, or was that something that you kind of leaned onto in other ways?
Not really. Yeah. So, I'd been doing 3D printing in high school, and then, a little bit in college here and there, more so like just plastic stuff. And I would say how I got reintroduced introduced to additive manufacturing instead of 3D printing was I had the opportunity to do a summer internship at the Alcoa Technical Center, ATC in Pittsburgh. And they had an M270 machine, and I had the opportunity to get involved with some projects there. And I was like, wow, this is really cool technology, and it's really going to change the way we make things. That, and it's kind of really starting to take off. And I quickly realized, I was like, oh, like when people invented castings and they, turned that into a more viable production process, and like forgings and things like that, this is an opportunity to really get in on like building something that's going to be used every day. People are going to look back on it and be like, oh, I wonder how they came up with all these rules and this knowledge. And so that's kind of what drew me to, keep pursuing it.
And I imagine too, like people recruiting for jobs and running M290s or Renishaw systems or SLM system, you get a resume with someone that has like a welding engineering degree, like you hit the jackpot, right? Because you got the material science, mechanics, electronics, and so what, and even that first job is kind of at the Alcoa Tech Center, what were some of the skills that you kind of gained in that first experience in terms of learning about the technology? Were you running machines as well as kind of being around the space?
No, so I didn't really get a chance to run the machines too much. I think, at the time there's still a lot of, unknowns as far as how to, do health and safety with handling powder and things like that. And so, I didn't get an opportunity to be hands-on with the machine as much, but I would say some of my initial starts were more so on more, I guess, manufacturing maturities type of things. Well, it was a mix. So some of it was, let's look at and understand, what happens to the parts as they go through heat treatment cycles. So a lot of CMM measurements and analyzing it to see how, residual stress relief, turns into, displacement of different datums on some of the parts they're looking at, which I probably can't talk about too much. But and then the other side of it was I got to work with on sort of more of the processing side with modeling actually. And so we were running some thermal models to look at how can you efficiently model the residual stress buildup as the part gets built to try and predict some of that distortion and how it might build up during the build process and then be relieved. So that was, I kind of got to do maybe a little bit of full life cycle of, some predictive as well as, actual experimental, actually validation for those predictions, which was a lot of fun.
And was this remind me again, was this an internship that you were doing? Or?
Yeah, this was an internship. So over the summer in May through August 2014.
Okay. And how did that experience influence you going back to school and thinking about kind of what was next for you as either the next summer or kind of a further career path? Did that kind of say like, hey, like this additive manufacturing stuff there might actually be a career here other than just being an engineer who uses the technology?
Yeah. So first thing I did was I started talking to some of the professors and said, hey, I really enjoyed working with this technology. Who's working on it? And got linked up with Professor Zong and one of his grad students, Hey Yoon Song, who I think is now at EWI, but they were doing some work in the lab on a research program looking at building Inconel 718 and DMLS systems supported versus unsupported, and seeing how the cooling rates were affected, the material properties, microstructure. And so I started helping them in the lab and to get some more experience. And I really enjoyed it. Definitely balancing that with like my senior year of college and senioritis was a bit challenging at times, but it was really great experience and set me up for kind of my next steps after graduation, where I was really looking at trying to find a role to continue this newfound passion.
So one of the things we rarely get into on these podcasts is like the actual mechanics of like finding a job after graduation. So like, can you like step through that? Like, did you have like link ups from your internship or your professor, or were you throwing out resumes? Like tell us a little bit about how did you get that first job after graduation?
Yeah, so I will say I was pretty spoiled. The welding engineering program, it's like I said, it's pretty unique in that there's not many graduates, and so there was a lot of jobs. So I think I applied, with my resume to either some folks who came in for like info sessions, because there's actually a number. I would say each year we maybe get like 8 to 10 individual recruiting sessions, not just for Ohio State Engineering, but Ohio State Welding Engineering. They come in specifically to recruit from our program. And so I met some folks through that and, went on to apply for jobs and, had a number of interviews, and I was really lucky to, get a few offers, and then also applying, through just putting my resume out there. And so I think, I interviewed with probably 6 or 7 different companies, and I was very fortunate that the job market was great. And I think I, had 6 offers, and turns out the actual last job I applied for was Boeing, and it was like pretty much like a month or so before I graduated, or 2 months before I graduated. So I ended up, getting an interview with Boeing, and they're growing their research and technology team in the metals area. And I guess I ticked a lot of the boxes as far as additive as well as joining. And so that was, that was the offer I ended up taking to go work there.
I know Boeing's always somewhat secretive in some of the stuff they're doing, but can you tell us at a high level, like what sort of work was kind of Boeing going after? Obviously aerospace, but like theoretically, what were some of the objectives they were trying to hit with additive?
Yeah, so well, I guess actually it was interesting. The first few months I didn't even touch anything additive, even though that was kind of the agreement for what I kind of signed on for. But it turns out there was kind of a fire to be put out on the manufacturing side, and I got really deeply involved with some super plastic forming diffusion bonding processes up in the Seattle area, and that was a really cool program. But yeah, after like 4 months of kind of putting that fire out with the team, I started getting into additive more. Really, I would say what that looked like was it was just really starting to picking up a lot of steam. They had been working in the technology for a number of years, had actually even flown parts, not only from a plastic standpoint, but also or polymer standpoint, but also the metal side. But it, had a number of programs here and there. And then now they're looking at it more deeply of how they can pervasively get the technology implemented across their business units. And so I had the opportunity to lead one part of a Pathfinder project, so-called, where it was, hey, we're going to pick a technology, we're going to pick a part, and we're going to figure out what it actually takes to get this part built, certified, build a supply chain, build some specs. And so that's sort of what I got I got tasked with, and it was a lot of fun working with, being pretty new out of school and learning all about aerospace qualification and certification and the hurdles involved with that, from not only internal, but also FAA. And I got to, work a lot with electron beam melting. So RKM powder bed process. And so it was kind of got to do the full life cycle of looking at parts and use cases, and meeting with, the actual product teams and saying, hey, what are the requirements for this part? Where additive stands today, does it make sense? Maybe a little bit less on the business case side, because this was really a technology push. But really, trying to figure out where's additives home at the Boeing company. And so that was a lot of fun.
And with that, I mean, like, theoretically, you find a part, you find an application. Was it the consensus that you kind of mentioned building a supply chain? Was it the idea that Boeing's not going to say this is successful, they're not going to buy 100 RCAMs to build all these parts internally, right? They need to vet some series of vendors outside of that network of their own kind of doors to do that. So was that kind of the case, or because that seems even today like pretty immature, right? Like, even if you find a part, right, how many places can you go to go get it manufactured?
Absolutely. And believe me, those were the discussions. The aerospace primes have traditionally gone through cycles of make versus buy, depending upon the business environment of the day, and what the executive team decides of vertical integration versus a diverse supply chain. Those were discussions being had of whether this technology lived at Boeing or if it lived in the supply chain more so. So at the time, I think it was more so definitely looking at the supply chain. And so I got to meet a lot of great folks also working in additive, at service bureaus, or even, some of the tier ones who are starting to dive deep into it, and working on these technology development roadmaps with them, and understanding, one, they have printers in house, right? And understanding, trying to learn the technology from them as well. Because a lot of the learning happens, actually putting the build files onto the machine and pulling out scrap parts and learn how to fix it, right? That was kind of, at the time, it was, like I said, a lot of the supply chain, but those discussions were still happening, right? And now I think here in 2019 or whatever, Boeing Additive Manufacturing is alive and well, where they are producing things internally for the Boeing company with their own machines. So obviously, since I left, there was some further decision making of bringing the technology more in house, right?
And so, what was the step after Boeing, and kind of maybe fill in the blanks? Because right now I'm talking to you from Ohio State. So what was the next steps?
Yeah, so I left Boeing and went to Northrop Grumman's manufacturing technology team. So this was embedded with their aerospace unit, business unit. So versus my role at Boeing, I was in sort of this corporate technology group where we supported each of the business units who made the products, whether it was BCA or BDS. And so that was always kind of interesting, because you're sort of a little bit on the outside, kind of looking in sometimes, and trying to anticipate their technology needs versus being attached to the aerospace business sector. Was we were a little bit deeper embedded and able to gain more traction with some of the programs sometimes, which was nice. And but that role, it was I kind of moved from supporting advanced joining and forming projects as well to living, breathing, sleeping additive every day. And it was, it was it was a lot of fun. Really enjoyed, working with that team. I, worked with some great engineers and really some of the coolest products, out there. So that was great. I got exposed to more technologies and more building supply chains and developing material allowables and understanding, certification approaches for more on the military side instead of the commercial aircraft side, which is actually, fairly different. The governing bodies and the regulatory bodies are obviously different. And so is the product profile itself of what, where does the value really lie, as well as, part counts in general too are a lot different. So, it was a great experience, seeing more of the defense side of the aerospace manufacturing industry.
So what's the big difference? If you're a defense, you have a blank check and it doesn't matter as much.
No, not at all. It's just, from the biggest difference I would say is one is like, part counts. And then also, the overall, and maybe the commercial side of it, there's a little bit less, cost out initiatives as much, but also just like risk tolerance for the mission. And the FAA has a very fundamentally different mission than, the DoD, right? So there's, the qualification approaches are just, they're just different. And if I had to put my finger on one thing, it'd be difficult to do.
And so explain what you're doing now. What are you doing at Ohio State?
Yeah. So about, I guess, 2.5 years now, I left Northrop and came to Ohio State as a additive manufacturing engineer. And really, that's my title. I would say researcher, however you want to look at it. We're definitely on doing applied research. And I would say my job has definitely changed a lot. Working in versus working in a large corporation where you have a really deep bench of collaborators, right, who are all aligned with the same mission. Versus being here at the university, we're definitely still a team, but especially where I work, the Center for Design, Manufacturing Excellence, it's, a much smaller team, and everybody also has sort of their own programs and projects they're working on, which are supporting a lot of different external customers. So going in a lot of different directions. And so it's definitely more of an entrepreneurial environment, I would say. It's, you have to, here it's a lot of, if things are going to move, it's you pushing them, and you don't, it's not as much of a, 5-6 person team moving things forward. It's definitely, you and maybe a couple other folks really pushing things forward, more or less, kind of on your own, which is, like I said, it's very entrepreneurial, and for folks, like myself, I thrive on it, where, not only do I get a, steer the ship, but I also get a, go downstairs and shovel the coal into the fires, right? If that analogy works. So yeah, it's a lot of hands-on and ownership.
And what's kind of the main mission there of the additive manufacturing kind of as a group or agglomeration at Ohio State? Is it really to serve students? Do you do a lot of commercial work with industry, kind of research grants, all of the above? Is there kind of a cohesive thesis that or body that kind of is centered around additive, or is it kind of pockets here and there, and maybe there's overlap when there's overlap?
Yes, I think overarchingly, the mission is to, grow, grow manufacturing here domestically and across the world and mature it. Now, what that embodies or what shape it takes on is, sometimes a little bit different for different folks. But I can say CDME being a little bit outside an academic unit, we definitely, support faculty who, their mission is a little bit, different than ours. They maybe are a little bit more focused on basic science, as well as, supporting graduate student education, and, of course, instructing, undergrads. Our mission more so is, I would say, focused on, partnering with industry to help them, grow these technologies from, basic science to something that they can, take hold of and bring into their own manufacturing processes. And then with that comes the aspect of, developing undergraduate talent, to feed those, companies, their future employees. And so we found a really great, sort of, say, terrible word like synergy, but we found symbiosis maybe. And, not only are they looking to mature these technologies, but they also need, the future talent for it. So we've kind of married those two together to do our research programs instead of with, the future PhDs and master's students, but more so with undergraduate students. So it's kind of year-round capstone projects almost, except, some of these projects, they don't live and die within a semester's time, coinciding with graduation. We are constantly hiring. We might have one project last for 2 years, and we're constantly cycling students in and out of it as they, mature through the university, and they're getting hands-on education, not only, from the classroom standpoint, but also this is what an industry project looks like, and this is what it feels like, and this is what it tastes like, and this is exactly what you're going to be doing, once you graduate. So I think there's been a lot of value in that. And I'll be honest, if you would have asked me when I left Northrop Grumman and was like, oh, why are you going to Ohio State? I probably would have told you, well, I want to work, I want to be hands-on with my research, and I want to, lead my own research. It never would have dawned on me that the best part would have been working with undergraduate students and helping them develop the skills to go out and get jobs and internships in industry, which is by far the best part, whether it's, like I said, my students go and get internships, or them, graduating and getting a job and be like, hey, Jacob, I'm working here now. Thanks for the help, learning a few things along the way at Ohio State. So I would say that's been great.
And what, in your most successful students or your students that are doing well, like, is there a common factor that helps them engage with companies successfully or engage with these projects in a way that is beneficial, both certainly for themselves, but also for the companies?
Yeah, definitely. Willingness to ask questions and willingness to try without giving up. I think the folks who, really lean into a problem and try and, take it on, own it, and, work on it without maybe throwing their hands up and asking questions about it right away are definitely, they do really well. And they really develop a lot of skills and independent thought and thinking that way, that serves them in their future careers. And I think, and that's maybe it's even less of teaching them necessarily hands-on skills, like, hey, this is how you run a tensile tester, or this is how you do metallography. I think that's one of the skills that I try to pass on the most to the students and get them to really, learn as they're working here and working on the team. So I think that's probably the biggest skills.
And how do you teach those? And how do you teach those students that may not have that ability? Maybe some are introverted, some haven't been in a work environment, so to speak. Is there some things that you've seen people grow their skill set in that may not come naturally to some people.
Oh, absolutely. Probably for me, the biggest part of that is, one, not everybody's the same. And so you really need to like personalize it, I guess, and really try and, communicate with that person to try and understand what is it exactly that they don't understand. And a lot of it is, I think even the most powerful thing is self-reflection and like understanding, like thinking more like, what am I doing? Like, how can I change my communication to help them? And like, that's been definitely the most useful, is like self-reflecting, and like, it's probably not the fact that they can't do it or understand it. It's really, I need to present it in a way that clicks with them. And like, I do this the same way. I didn't mention before, but I'm also a PhD student right now here. One of the best ways that I found to learn is, I use YouTube all the time. And even if my professor that I'm taking a course with maybe didn't explain in a way that clicked, if I watch 5 other lectures and hear the same thing explained 5 different ways, chances are one of those is going to click with me. And so that's how I kind of try and approach it too, is, yeah, it's like I said, it's not that the problem is too hard for them. It's explaining the problem in a way that helps them click in their way of thinking.
Yeah. And on the flip side, do you see companies who engage with you for maybe a couple of different projects get better at the process of either selecting students or working with students or engaging people within the additive manufacturing space?
Yeah, I think so. Because in a way, it's kind of like, I don't know, like picking something off the shelf. If there's 10 options and you try all 10 options at a store before you buy one, chances are you're going to get the best one that you want, right? And so, these companies working with us, they get to see, 10 different students or something like that, and not to boil students down to commodities or anything like that. That's probably, I'll probably get tisk for it later. I don't know, but you get to see what you like, and you get to see what works well for you, and which personalities and which, skill sets and things like that, and backgrounds, because these are multidisciplinary teams. And, maybe somebody said, oh, I need a mechie for this problem. And then they look at the problem and we work on the problem together. And it turns out, no, it was actually somebody with a data analytics background actually helped them the most. And so I think that's one of the biggest value propositions too, is it's a little bit of a try before you buy kind of
Sure.
Approach.
Yeah. And what's kind of been the uptake of people kind of continuing on with some of these companies, or continuing on in the additive space, like kind of once they get see some of the manufacturing, like are people sticking with it?
Yeah, so a few have, and it's part of it is, I've been here 2.5 years. Some of this is a little bit of a long lead cycle.
Sure.
Past year has obviously been pretty wild. And then at the same time, these folks are also individuals, and a lot of times, it comes down to, geographic type of things, right? When they're picking on, careers or future jobs. So, I don't have many former students who have gone into additive careers yet. But, like I said, there's, it's hopefully only going to grow.
And so what's your PhD on? Can you give us a preview?
Welding Engineering is the degree. And my research. So I actually just defended or took my candidacy exam a couple of weeks ago, and passed that, thankfully. And so I'm very excited to have that off my plate. And my thesis is going to be primarily focused on looking at what happens in multi-laser additive manufacturing, and looking at the stitching for different alloys, and understanding how can you develop better strategies for stitching together large parts for you can, make sure you maintain isotropic properties. Because I think the last thing anybody wants is to have it act like a welded joint where you have to take a knockdown, from having, say a stitched region. That's the last thing we want, right? And so we really need to do the work to understand how can we maintain integrity of that. And or if it is slightly different from a material standpoint, how can we, accommodate that? So
the idea, if you have a 416 140 laser system, you can have some uniformity or at least some understanding of what your part properties will be based on the scan settings and things like that.
That and the other part of it too is really, I think people in the additive community, they like to forget that there's, or especially maybe folks who don't run the machines every day, is they like to forget that there's a machine that is delivering a laser to their powder. And the whole mechanisms behind delivering that laser to the powder is actually pretty complex. And there's, components of the machine that get larger or change over time, especially as they get warm. And so understanding in that cycles, right, as, the build is happening and or after the builds and you start new builds. And so digging into understanding what aspects of a machine and the optical train, optical components and the machine itself are going to help you get maintainable, repeatable quality. And so that's been a lot of fun for me, is trying to dig into that as more of a metallurgist, going back to, the lasers and the scanners and the optical bench itself, and understanding, why are we seeing laser misalignment? If my lasers are going to be misaligned, how can I accommodate for that in the process to maintain integrity? So, which has been a lot of fun.
And what's your general thought on kind of the push for more lasers in the industry? It seems like if you want to go faster or get bigger, that's kind of like specific, like DMLS systems, right? Like, but in the last year, we've seen 12 or 16, I can't remember the number, systems from some companies, but some companies just want to focus on, hey, we're going to do one laser very well or up to 4 lasers very well, and just make sure our machines are like dialed in. And so you buy one machine and it's going to act like the one before it. So do you have any thoughts on kind of all the experience you had of like, what's a general consensus that people are looking at when they talk to you or do projects with your students or Ohio State?
Yeah. So, to a certain extent, the benefits that you're going to get from putting more lasers into one area is, capped, right? And then, the other side of it is recoat time. And so, I feel like there's still a lot of room for optimization of recoating the powder bed. And you see, folks, I forget, maybe the machine maker out of Australia that's doing like continuous recoating as, the part is being built and the lasers never turn off. I think that's a, really cool concept to, increase the profitability and productivity of the AM. And then, folks like, Surratt, who is, introducing like tile printing for AM and really reducing the amount of, time for the printing layer. So, when I think if I say, what the opportunity spaces are, definitely adding more lasers is helping and creating and allowing you to create bigger parts, right? Because your laser scan field can only be really so large for a single laser. And so at some point you'll need to move them out or, put them on like a gantry system, like the GE Atlas system. So there's definitely, and there's in our, current configuration, whether or not the 12 lasers is the maximum, like SLM, figured out and said, yes, 12 lasers is like the maximum we'll get from benefit from, having this machine. I would say that's probably close to it. When we talk about single mode gassing beams, and there's a lot of other opportunities to make the process go faster. We're talking about layer thickness, SLM, I think, has done a lot of work in looking at printing 30, 50, 90 micron layers, and understanding, can we use that to increase our productivity, which I think is great and deserves more attention as well. And, then you'll have to start talking about surface finish, and then finishing comes into play, but I definitely think there's a lot of room, runway left to increase productivity and make, additive manufacturing, cheaper and more affordable. And I kind of just been, rambling on some of my thoughts there, but yeah, definitely. And then some of the things that, I'm also interested in is, can we use multiple lasers together to do really interesting things from a material science standpoint? So pretty soon we'll be having a new machine come in that is more suited to having, dual lasers operating in tandem with each other. And really excited to, start working on that to see, are there opportunity spaces and, alloys that have poor weldability, to, use multiple lasers that are tailor microstructure and control solidification, and control the temperature gradient. Or, some folks are even looking at residual stress relief in situ. So multiple lasers doesn't just have to be more productivity. There's other opportunities, I think, for it as well.
For sure. Well, awesome. Well, thank you so much for joining the show today. It was a really good conversation, and look forward to seeing the results of some of your research and what your students are doing as well.
Oh, absolutely. Thanks for having me on, and enjoyed I guess more of a one-way chat for me, but really always happy to talk additive.
Awesome. Well, thanks so much.
Absolutely. Take care.